Hello students. So let us discuss another important chapters in optics after diffraction is polarization. So as we know that light is an electromagnetic waves which consisting of an electric and magnetic field vectors and which are perpendicular to each other, and both are also perpendicular to the direction of propagation of the light waves. So these basic things already you have learned in our previous classes. So here our chapter is polarizations. When we say that the light is said to be polarized. So here the beam of light, so whose vibrations are confined to only one plane containing what optical axis and the direction of the incident waves. So that phenomena, so we are calling it by what it is polarization. It's okay. It is also defined as the phenomena of restricting, means confining, the phenomena of what? Restricting the vibration of the light waves in a particular directions in a plane perpendicular to the direction of the propagation of the light waves is called as what? Polarizations. What it is? So here you are restricting the vibration of the light waves in one particular directions in a given plane perpendicular to the direction of the light waves. So that phenomena, so we are calling it by what it is the polarization. It's okay. So let us define some more terms. So what do you mean by ordinary light? Or it is also called it what? Unpolarized light, plain polarized light, so as well as what? Partially polarized light. So when you say that the light is unpolarized, if the light waves is having vibrations along all possible straight lines, that means the vibration of the what? The light waves is along what? All possible straight lines in a plane perpendicular to the direction of what is propagation of light is called as unpolarized light. So this is the geometrical representation of your what is unpolarized light. So this also and what representation of geometrical representation of our what is unpolarized light. So here the vibration of the light wave is taking place along all possible straight lines in one particular plane perpendicular to the direction of what? The propagation of the light waves is called as what? Unpolarized light. Next, when you say that plain polarized light, suppose if the light waves are having vibrations only along a single straight line. That means what it is? The vibration of the light waves are existing only along a single straight line in a plane perpendicular to the direction of propagation of the light is called as a plain polarized light. So this is the geometrical representation of our what? The plain polarized light. So here the vibration of the light waves is taking place along only a single straight line in a given plane perpendicular to the direction of propagation of the light waves is called as plain polarized light. It's okay. Next, when you say that the partially polarized light, so here the vibration of the light, the light is having a more vibrations along one particular directions than in the perpendicular to the direction of propagation of the light is said to be and what? The partially polarized light is what it is. If the light waves are having more vibrations along one particular directions than in the what? The perpendicular directions is said to be what? The partially polarized light. So see here, so we are having the light waves are having more vibrations along one particular directions than in the what? Perpendicular directions. So then this is said to be what? The partially polarized light. So this is the what? The geometrical representation of our partially polarized light. It's okay. So let us know some more things, basic things regarding. So when do say that the plane of vibrations and the plane of polarization is okay. So here, when a beam of when a beam of light is passed to a certain crystal, such as calcite or it may what tourmaline crystal, what it is, whenever unpolarized light, or you can call it a beam of light, is passed to a certain crystal, such as tourmaline crystal, the light gets what polarized, and its vibrations are restricted to only one plane. It's so here this first picture, the dramatical picture, indicates and what the unpolarized light, the unpolarized beam of light, or we can say that we know that ordinary beam of light, when it is passed to a certain tourmaline, certain crystals, so which is nothing but here is a tourmaline crystal. So on passing to your crystal, the light gets what polarized, and the vibration of the light waves are restricted to one particular plane. The plane in which the vibrations takes place, so that plane we are calling it what? The plane of vibrations. So here the PQRS is our what? The plane of vibration. It's okay. And the plane in which there is no vibrations occurs, the vibration of light waves is taking place, so that plane we are calling it what? The plane of polarizations. So here that's UVWX is our what? The plane of polarizations in which there is no vibration of the light waves taking place, so that plane is perpendicular to the your what? Your plane of vibrations. Okay. So these are the basic things so which we require for the development of our chapter of polarizations. Okay. The first concept that is mentioned in your syllabus is Huygens theory of double refractions. Before that, so one more thing, the how to produce, so how to get polarizations. So the polarizations can be produced by different methods. So some of them are the polarization by reflections, refractions, or polarization by double refractions, and the polarization by selective absorptions. That is also called it what? Dichroism, and that's polarization is also obtained by scattering of light. So these are the few methods which are used to produce our polarizations. The light can be what? Polarized. So here we require what you mean by polarization by double refractions. When a beam of light is passed to a certain crystal, such as calcite, the two refracted rays are what? Obtained instead of a single rays. So the phenomena is called as what it is? Double refractions. What it is? When a beam of light, that light beam is passed to a certain crystal, the two refracted rays are obtained or produced instead of a single ray. So this phenomena is, we are calling it by what is? Double refractions. This was what is invented in the year of 1669. Okay. So here, when the what are those two rays? So here the two rays are named it as when that crystal is rotated about the normal, passing to the ink dot, the rays, the image which remains stationary. So that image he called it by what? Ordinary image, and the rays coming out of that ordinary image is called as ordinary rays. What it is? When that crystals, that calcite crystal is rotated about the normal, passing to the dot, the image remains then stationary. So that image they have called it by an ordinary image, and the rays coming out of that is called as ordinary rays. And the image which rotates around it is called as an extraordinary image, and the rays coming out of that extraordinary image is called as extraordinary rays. So this is the what things is taking place in case of what? Double refractions. When that a light beam, the beam of light on passing to the crystal, the two refracted rays are what? Obtained. The two refracted rays are nothing but your what? Ordinary and extraordinary images are rays. Okay. So here, so your mentioned syllabus is Huygens theory of double refractions. our scientist Huygens extended or explained the phenomena of double refractions by using a secondary wavelets. Whatever that double refraction phenomenon is there, so that phenomenon is explained. So with the help of a secondary wavelets. So what are the facts that he has observed in case of double refractions according on the basis of secondary wavelets? According to him, in double refracting crystals, each points, whatever the points which are existing on the surface of your crystals, behaves two wavelets. What is in a double refracting crystals? So each point on the surface, so behaves as a two wavelets. So what are those two wavelets? So one wavelet he called it by what? Ordinary wavelet. The second one is he called it what? Extraordinary wavelets. Okay. The next observed facts is ordinary wavelets are isotopic in nature. So when do you say that that is in isotopic in nature? Its velocity is same in all the directions of our crystals. Whatever that velocity of our ordinary wavelets are there, so their velocity is same in all the directions of the crystals, and the wavefront is in what it is spherical in nature. And wavefront is in what? Spherical in nature. Next, the two refracted. Whereas this is about what is ordinary rays. What about our extraordinary wavefronts? So the extraordinary wavefronts are in what? Anisotropic in nature. So when we are calling it in anisotropic in nature, its velocity is different in different directions of our what? Inside our crystals. It is in what is in anisotropic nature, so that its velocity is different in different directions, and the wavefront is in ellipsoid in nature. Okay. So these two your refracted rays, whatever the ordinary and extraordinary rays are there, they travels with the same velocity along the what is optical axis. Along the what is optical axis. Hence the two wavelets touch each other at the optical axis. Okay, that I will confirm. So in case of negative and positive crystals, what is whatever the two rays are obtained on passing to the crystals, the two refracted rays, the two rays travels with the what? Same velocity along the what is optical axis. So hence, so those two are what? Touch, those two wavelets touch each other at the optical axis. Okay. So here, so this is the what? Theory. So provided by our Huygens for the what? Double refractions. In certain crystals, the velocity of our extraordinary rays is much faster than our what? Ordinary rays, except along what is optical axis. In some other crystals, it is slow. What is whatever the velocity of our extraordinary rays is there, it is somewhat faster than that of our what? Ordinary rays, except along what it is optical axis. In some other crystals, it is what is slow. So depending on that, according to that, so you are having two types of what is crystals. One is negative crystals, so other one is called it by what? Positive crystals. So see here, what do you mean by your negative crystals? Once you know these pictures, so it is easy to explain the things which is happening inside that our negative crystals. A crystal in which a spherical wavefront, whatever that inside picture is there, the spherical wavefront. A crystal in which the spherical wavefront lies within the what? Elliptical wavefront is called as what? A negative crystal. What it is? A crystal in which a spherical wavefront lies within the what? Elliptical wavefronts is called as a negative crystal. So in negative crystals, the velocity of ordinary rays as well as what? your extraordinary is same along the optical axis. So this, whatever the center line is there, so this is your what? Optical axis. The velocity of ordinary and extraordinary is what? Is same along the optical axis. So that the refractive index of its ordinary as well as what? Extraordinary is what? Remains constant. At what point? Along the optical axis. Next, velocity of our what is ordinary is same along all the directions. So inside that our what is crystal sits. In case of what is your negative crystals, the velocity of ordinary is what? Same in all the directions. That's why the refractive index of ordinary rays remains constant inside that negative crystals. But whereas that your the velocity of our extraordinary rays is varies. How it varies? So its velocity is minimum and it is equals to that of your ordinary rays along our what is optical axis, and it is a maximum in the directions perpendicular to the direction of the your what optical axis. Where it is extraordinaries, velocity of our extraordinaries, it varies and it is a minimum equals to that of our ordinaries along the optical axis, but it is a maximum in the directions perpendicular to the what the direction of optical axis. Okay, so these are the what? So observed, this is the things which is taking place in your negative crystals. And one more is another thing is in case of your what? Negative crystals, the minor axis. So here this outer one is our elliptical wavefront, the inner one is our what? A spherical wavefront. Its minor axis of our what is elliptical wavefront is this one. Whatever the central line I have drawn, so that is the what? The minor axis of our what? Elliptical wavefront. That minor axis of our elliptical wavefront coincides so with the optical axis. This what is the minor axis of our elliptical wavefront coincides where what it is minor axis of our what? Elliptical wavefront coincides with the optical axis. So whatever that optical axis is existing, so that axis is coincides with what? Optical minor axis of our elliptical wavefronts. Okay, next. So the two wavefronts, whatever that ordinary wavefronts and extraordinary wavefronts are there, the two wavefronts touch each other. This elliptical wavefront as well what? The one more is what? Your spherical wavefronts touch each other along your what is along the minor axis of the or what is minor axis of our what? Elliptical wavefronts. What it is? Whatever the two wavefronts are there, that's elliptical wavefronts as well as what? Spherical wavefronts. These two wavefronts are what? Touch each other along the minor axis of our what? Elliptical wavefronts. So this is the thing which is taking place inside our what? A negative crystals. It means how that ordinary rays and extraordinary rays are what? Its nature is changes. So inside our what? Negative crystals. Okay. What is the behavior of our ordinary and extraordinary rays in negative crystals? And let us discuss another type of crystal, so which is called as your what? Positive crystals. Okay. Once you remember this picture, you can define your what is the meaning of our positive crystals. In negative crystals, so see here the spherical wavefront is lies within your what? Elliptical wavefronts. So that one we have called it by words negative crystal. But here the elliptical wavefront, what is the elliptical wavefront is lies within your what? A crystal in which the elliptical wavefront is lies within the spherical wavefront is called as what it is? Positive crystals. Okay. So here the velocity of our ordinary rays as well as your what? Extraordinary is same along the what is optical axis. So that's why the refractive index of ordinary rays as well as what? Extraordinary rays is remains constant. So mu naught is equals to, you know, mu is what it is, the velocity of your what, ordinary and extraordinary is what, is same along the optical axis. So that you are having a mu naught equals to mu e. That means the refractive index of ordinary ray is equals to what, the refractive index of extraordinary rays. So is what, where is existing along the optical axis of that given crystal. And another important properties is taking place inside a positive crystal is the velocity of your ordinary ray is same in all the directions. So in case of what, a positive crystals, but whereas the velocity of our extraordinary ray is varies. How it varies? Let's see here. It is maximum. The velocity of very extraordinary ray is maximum along the what is optical axis. But whereas in case of negative crystals, the velocity of our extraordinary is what, minimum, and it is equal to that of your ordinary rays along the optical axis. But in this case, it's what, maximum along the optical axis, but it is minimum in the directions perpendicular to the what, optical axis. So this is the what behavior which is taking place inside of what, positive crystal it is. Okay. And next one is another thing is what is the two here what is the elliptical wavefront is what, lies in this case, the elliptical wavefront is lies within your what is a spherical wavefront. So in case of or what, positive crystal it's okay. Next one is as the two your what wavefronts touch each other. So this your spherical wavefronts as well as what is elliptical wavefronts touch each other along the, this one is major axis, touch each other along the major axis of our what is ellipsoids. The two wavefronts ordinary is what is spherical wavefronts as what, the elliptical wavefronts touch each other along the major axis of our what, elliptical wavefronts. So this is the informations and explanations regarding what, positive as well as negative crystals. Okay. So in the next class, so we will discuss the half wave plates and quarter wave plates. It's okay. Just go through it. It's very easy one and interesting. It's one already I have sent and notes on this. So just go through it. Okay. Thank you.